All right, so we're up and running here. So we got a little homework on sinusoids. So the sine function measures height in the unit circle. And as we traverse the circumference of the circle, the heights vary between 1 and -1, and no radius lengths. When we start our journey around the circumference, the height is in the middle, 0. The y-axis for cosine functions, it feels a little dyslexic almost, because we're measuring widths. Widths go from 1 to -1. You know, as we draw those triangles, we can see as I draw this triangle, then that width just got smaller, and then it got bigger negatively, and then, you know, it comes back to where it started from. They're both called sinusoids when we start graphing, right? So what's really important over here is the sine of 0 is 0. You're right in the middle of the heights, 1 and -1. Whereas over here, the cosine of 0, that's a maximum width over here. And if I'm over here, I've got my maximum width. Can't draw the triangle, but it's maximum width of 1. Why is that important? Because if we're going to use these numbers like an artist would, you know, we got a palette and we can, you know, it's calculations based on 0 and 1, what this course is about. All right. So let's go over and let's practice a few of these sinusoids, see if we can get to be able to write these as quickly as we write the equation of a line. And once you understand trig, you can. So here we have a function in front of us. This is often kind of referred to as a two-step function because I'm going to take a date and time and I am going to give you an altitude. Okay, and I'm going to take a date and time and I'm going to give you another altitude. Okay, but the problem, or width measurement, you know, depending upon whether I'm using sine or cosine. But the issue here is we got to get ourselves on the circle. Okay, so there's two ways to do this. We can get on the circle and do it in terms of height, or we can do it in terms of width. And width means we're going to be doing a cosine function, and height means, let's see if I can get this. I should have erased the other circle first. Let's do this. Let's do our heights over here, and let's see if that's enough room for our function. So let's call it f of t. Well, we're starting with time. We're going to convert it to amounts, okay? And then I guess I'll just do the width later. Now, I want you to see them both. So let's do width here, right? And still a function of time. All right, let's see if we can nail these things. All right, so you've got two choices here. Most textbooks would say that it's easiest, and I think it is, to do this as a cosine function, because where are we at? We're at a max. And at this location, and this location on the circle, we haven't gone around the circumference yet at all. Which is a max, height or width? Well, this is a max. So this would be a nice cosine function to work with. All right, so I'll see if I can get some, but basically speaking, these are going to start the same regardless. We've got a 75 and a 65. So 75 and 60, so 70's in the center, and we got 5 here, and 70's in the center, and we got 5 here. Whether I write it as a sine or cosine function right now. It's an infinite number of ways to write these things. We're trying to find the easiest. All right, so what are we really doing? We're really taking a place on the circle, and right there is where we're going to start if we pick 0, or we're going to start here at pi over 2. Now, why pi over 2? Because that's where height is a max. This is where cosine is a max. Cosine of 0 is a max. Equals 1. Sine of pi over 2 is a max. Equals 1. So what we're going to do is write a linear function now. So if we're talking about widths, we're talking about cosine. And cosine is this one here. So we're starting at 0. And if we start at 0, we want this to be, I'm sorry, let me get my thoughts processed together. I'm starting with 1974. And I want that to be a max, and the cosine of 0 is a max, so that matches up with a 0. And then it looks like 74, 26, and 21. Am I right? My brain is a little slow. 26 and 21, so 47. So 47 years later, 2021, we've come back to the same place, but now we've gone around the circle once. So, well, no, actually, I'm doing it from this perspective. So I've got one revolution right there. That's one revolution, which is 2 pi radius lengths, 6.28 radius lengths, and I'm going here. So 1 pi, 2 pi, 3 pi. So I want this to act like 3 pi, because 3 pi is going to get me the widths. I'm going to be at a max, min, max, min, right? Max, min. So I went from max to min. That's 1/2 of a circle. So that's pi. Back again, 2 pi. Over here, 3 pi. Okay, 3 pi takes me to a min. All right, so this is what we want to write. So how do I make 1974 a 0? We know how to write the equation of a line now in our sleep. And I don't need to write 0 here. I will for this one time. We've changed by 47 years. And what's happened? We went 1.5 times around the circle, once around and a half. And so that is that equation. And obviously I don't need to write that. Now, same function over here for the sine function, except that this changes to pi over 2. Pi over 2 is the maximum height, and I'm at a max. So I'm using that as a template, as a place to start. I'm still traveling 3 pi, but I'm traveling 3 pi from pi over 2. I still want 1 revolution and a half, which takes me from a max to a min, which takes me from a max to a min. So I still want this, and I hope we've gotten good at this. So 2021 could be 7 pi over 2. Okay, so how does this equation change now? If I make it I'm going to use this because I've got pretty much everything written, right? This is still true. That's still true. But now that it's a sine function, to get to a max, I have to start at a different place on the circumference. And that's what I want you to practice until the middle of May, because I think you're capable of learning it. All right? But we got to keep talking about it. And if you can't learn it, well, that's basically the end of your math career. All right, so you got to keep thinking about this stuff. All right, so now I think I can go a little quicker. We've had the discussion, and I've got 10 minutes here to get the next 4 problems done. So going to start to zip. We'll write this 2 different ways. Y equals, we'll use the sine function, and we'll use the cosine function. So where am I? Oh, I'm at a max. All right, so I'm going to choose cosine. And I want 2023 to act like a 0, so 2023, x minus, sorry, t, I've been doing time, so let's do t minus 2023. And what do we have now? 1, 2, 3, 4, 5, 6, 7, 8 pi. Okay, so we got 8 pi. That's 4 revolutions. How long did it take? 2023 to 2040, 17 years, right? And we are looking at a range of 8 to 58. So what are we starting with to measure here? Well, we're measuring from the center, 33. So we got to get an amplitude of 33, and we're starting, I'm sorry, I wanted that over here. Rushing here. And how much are we going up and down by? 33, well, that's 5 and 2, right? So 25. We amplify by 25, because this is really giving us 33 plus 25 times all the numbers between plus and minus 1. That's really what's going on. So when is it the highest? Positive 25 and 33 gets us 58. I think it would be useful to throw 2040 in here. 2040 in here. So if we got 2040 in here, well, there's your 17s. Your 17s cancel, and you're right back 8 pi to where you started from for a output. Right now, if we were doing sine function, very similar, except once again, a max on the sine function, heights occur at a max at pi over 2, which is really 1.57 radius lengths, right? Radius lengths, which are called radians. So you've gone that far in terms of the radius. And okay, just got to start doing this more quickly. So now I want 2023 to act like, keep doing X, but I'm giving you a date, so I'll say T, 2023 plus pi over 2. Boom, and then you've got 8 pi in what? In 8 pi in totally lost my train of thought here. Change in 2023, 17 years. Yeah, so that's what you have for that. I think I did cosine. I got my nursing home room already lined up. It's only 7 miles up the road. So I'm in luck. All right. So we got another one here, but now we're at a min. Well, here's the width. Right, minimum width's over here at pi. Pi gives us -1. So I could build it off of that. There's 2 ways to do the cosine. One is to add a minimum, but I think it's easier if we think about going in the other direction. So I'm not going to do that. I think that would confuse you. So we're really at a location of 40, right? But I'm not going up to a max. I'm going down to a min, which means I'm going down in a different direction here. All right, that's the minimum width at 2050. So 31 is 9 units of change, right? I'm going to do a cosine function. And what happens when I drop in the first number, 2050? 2050, I did it again. T minus 2050. All right, let's put 2050 in. Okay, we got the cosine of 0. What's the cosine of 0? 0 is this place, cosine is width, that's a maximum width of 1. Okay, so I get 40 minus 9 times 1. Where's that put you? 31. So that's how that's working. Do I have an eraser? Yes, I do. Right. So I'm actually going to get this done before students start showing up. Good for that. All right, now I could have also done it as a, oh, wait a minute, did I count the pi? 1, 2, 3, 4, 5 pi. Then we went from 2050 to, did I ever put the other value in? Did I erase it? It was over here. I've got it on the board over here. So I know I'm changing by 7 years. All right, so 2057. I must have erased it. 2057. So I'm changing by 7 years. 7 years, and back to 49. So what I counted to 5 pi, I think, right? 1, 2, 3, 4, 5 pi, which is 2.5 revolutions. Go Che. Oh, I use the left hand. Go Che. All right. So, all right. Now, if it was a sine function, well, the sine function is minimum at 3 pi over 2. Right? Sine is height. And if I'm at 3 pi over 2, that's a -1. So I could put in 3 pi over 2. All right. So when I put 2050 in, I'm going to get that value, 3 pi over 2, which is -1. And if I want, then I'm going to put a plus there, -1 times 9, -9 plus 40, 31. Notice I'm having fun manipulating. That's going to be hard for you to follow for a while. It's going to take you several days. I'm going to need 5 minutes. Okay. Students are coming in. All right. So let me. We don't want to lose this. So I'm just going to graph this function as I see it. So what you want to start doing is getting your brackets in, and we're just going to do 1 period. 1 period of the sine function, positive sine function. It's going to look like that. We've got 8 and 50, so 50, 58, and 42. And so I want to put in a 0. Right? So I now know this starts at 0, 50. And 2 pi is when it ends, 2 pi. So I guess I want this to equal 1 revolution. So I have to solve it. Sure looks like pi. Gets me back to 50. That's that function. All right, we're going to practice these in class, obviously. All right, you're getting your first look in a homework sense. Right here, let me get this. Okay, hopefully you can see that. So this function, I'll be with you in food, just a few minutes. So this one here, I'm almost done. All right, so let me zip this. Again, I'm going to let 2x minus 8 equals 0, starting around the circumference of the circle, and 2x minus 8 equals 2 pi. All right, so if I make this 4, I can see I've created a 0, which is max. So I'm here. And because width is a max at cosine of 0, and I'm starting at 20, and I'm going up 30, so that's 50, and down to -10. There's your range. There's 1 revolution, and then all I have to do is solve this. And if I solve that, I get 8 plus 2 pi divided by 2, which is 4 plus pi. So that's where this ends. 4 plus pi will bring me back to where I started, 50. I'm gonna shut this off and let everybody in. We got people visiting. I'm hoping I'm not keeping them outside.